of the determinants is that when we multiply two matrices, the result, so if we have matrix C, which is equal to A times B, where these are both two matrices, then we have that the determinant of C is equal to the determinant of A times the determinant of B. Okay, so this is a useful property of the determinants of matrices. And here we can also mention the following, that so this means this is the determinant of A, and the determinant of A is equal to the determinant of A transpose. This is also true. Then we can say that if A, how can I denote this one? If A, we can write this in mathematical notation, but let's say it in words. If complete row is 0, what is the determinant of A?
Zero.
So it's 0. So if all the numbers in one row they are 0, the determinant is 0. Similarly, if a complete column is 0, then we say that the determinant of A is going to be still 0. Then we can say that so if A is an upper triangular matrix, then we can say that the determinant of A is equal to the product. We go from I to N. What we mean with upper triangular matrix, it's a matrix which looks like this: 1, 2, 3, minus 1, 7, 1, 0, 0, 0. So this is a 3 by 3 matrix, and all the numbers below the diagonal, they are 0. So now the determinant of this matrix is equal to the product of diagonal terms, which is 1 times minus 1 times 7. So in this case, the determinant is equal to minus 7. Similarly, if A is equal to, or is a lower triangular matrix, we get the same thing. So we can say something similar. The determinant of A is equal to the product of all of the diagonal terms. But think for a moment that we can have an upper triangular matrix, but what if this one is equal to 0? What is the determinant here?
0.
0, right? 0, because if this is the product here, this would be 0 times minus 1 times 7. Because of this fact, it's going to be 0. But we should not also forget that this has a complete column made of zeros. So that's a second argument. But now, actually, I don't know, or maybe I didn't think enough, or maybe I knew and I forgot, that no, I think that would not be the case. Think about this case and try to think about this one. What if, in a 3 by 3 matrix, what if all the diagonal entries are equal to 0? Can the determinant be equal to 0? So think about this. This can be different numbers, but make 0 the diagonal ones, and see what we get. Now, let's see this expression here. So this is a true identity, but imagine for a moment that A times A inverse is equal to an identity matrix, okay? Then we can say that the determinant of A times the determinant of A inverse is equal to what? What is the determinant?
1.
Is equal to 1, that's correct. So this means that the determinant of inverse of A is 1 over the determinant of, so let's write it like this, the determinant of A inverse is equal to 1 over the determinant of A. Okay? So here we have another important property of the determinants. Okay, so this is also here. Okay, now another thing is that if we interchange any row, if we do row J, interchange with row I, if we do this, the determinant of a new matrix B is going to be equal to minus the determinant of matrix A. So interchanging rows, this adds a -1 factor in the determinant. So this is what this this is how this affects the determinant. But this type of operation, which is expressed like row 2 star is equal to row 2 minus lambda row 1, this does not change the determinant of the new matrix. So we can say here that the new determinant of the new matrix is equal to the determinant of the previous matrix. So this is we imply this in here. Okay. So and to find the determinant of matrix, it's often useful to convert a matrix A into an upper triangular matrix, and then a lot of calculations would be relatively easier. Can you find the inverse of this matrix? When we ask this question, what could be the first thing that you can check for? So the question is, find the inverse of this matrix A. What is the first thing that you have to check for?
Determinant different from 0.
Yes. Can you check what the value of the determinant is? Can you calculate this? Okay, do you have any answer here?
Is it 0, the determinant?
Did you get a 0?
I think it's 0.
So if this is true, if the determinant is equal to 0, we say the A inverse, it does not exist. In fact, this one if you watch carefully, you might notice that there is a relationship between the rows. So the three rows, they are not linearly independent. What does this mean? This means that that we essentially have two rows, because which means that the third one is full of zeros, so the determinant will be zero. But how could you notice this one? Well, it's not all. I wrote them on. Or we can notice the following. What happens if you add row 1 plus row 2 divided by 3? Can you check this? You have row 1 plus row 2 divided by 3. You have 1 plus 5, 6 divided by 2 by 3 is equal to 2. 2 plus 7 is 9 divided by 3 is 3. Minus 2 minus 1, it's minus 3 divided by 3 is minus 1. Okay, so this is going to be equal to 2, 3, minus 1. So this means that row 3, it can be described as, let's say, a constant A1 times row 1 plus a constant A2 times row 2, right? And this A1 and A2, they are both 1 over 3 plus 1 over 3. So if this is the case, that means that row 3, we can completely remove row 3 because it's not carrying any information. And if you try to obtain the reduced row echelon form from this matrix A, you are going to see that one full row it will be full of zeros. And you know that if you have one full row with zeros, the determinant is 0. If the determinant is 0, then the inverse does not exist. A second. Okay, so here we have an important rule, which is a Cramer's rule, which states that for any matrix which is a square matrix n by n, and the determinant is different from 0, then we can use the ratio of the determinants to obtain the solution of Ax is equal to b. If x is a vector which is composed of x1, x2 up to xn, xi can be found as the ratio of the determinant of the modified A divided by A. But here A star, this is the modified matrix, has the column of xi substituted by b. Okay, so this is what we could say, and we can have an example. X plus 2y plus 3x, this is equal to 7, minus x plus 2y plus z, this is equal to minus 3. Then 4x plus y plus z, this is equal to 5. So these are, so here we have...
Is it z or x in the first equation?
Z. So this is Z. Thank you for noticing this. And here we can say that the B, the answer vector, this is 7 minus 3, 5. Okay, and the matrix A here, this is equal to 1, 2, 3, minus 1, 2, 1, 4, 1, 1. And in order to check for possible solutions, the first thing that we do is to determine what is the, to check the value of the determinant. Can you check whether the determinant is 0 or something else? Can you, yeah. What do you get for the determinant of A? we get 2 minus 1, that's 1, minus 2 times minus 1, minus 4, minus 5, plus 3, minus 1, plus 3 times minus 1, minus 8, minus 9. Minus 9, so this is minus 27, minus 37, minus 38. Is this correct? This is what I find. Is this correct, or we have here 1 minus 1, 4, 2, 2, 1, 2, 2, 1, 3, 1, 1, okay? Is this good? Minus 1, 1, minus 2 times. We have a mistake here, so this is, no wait, that's 1 minus 8. Yes. No, minus 27 plus 10, minus 6, 17, this is minus.
Professor, it is minus 16.
Minus 16, yeah, okay, that's correct. That's minus 16. It was, I thought for a moment, I was considering that this is minus 1 times 1. For a moment, I was just considering these to multiply with 3, but that was a mistake. So the determinant of this A, this is equal to minus 16. Now the multiplication for, let's consider the following. So AX, which is will be the modified matrix A, but AX, because we know in this coefficient matrix, the first column belongs to what? To which variable? The first column belongs to X. The second column, they are the coefficients of Y, right? So this is the X. This is the Y. And the coefficients of 3, 1, 1, they are the coefficients of Z. So let's first identify what is the, and by the way, it's different from 0. So the modified version of A is going to be the following. Here we have 7, minus 3, 5, 2, 2, 1, 3, 1, 1. Okay. The AY, this will be equal to a matrix which is 1, minus 1, 4. Then here we put the 7, minus 3, 5, 3, 1, 1. So here we need to find the determinant of AX, okay? Here we need to find the determinant of AY, and once we find these, we can easily say the following, that X itself is equal to the determinant of AX divided by the determinant of A, okay? And if we find the determinant of X, AX, this is minus 16 divided by minus 16, we get 1, okay? And then the value of Y, which is an unknown value, this is equal to the determinant of AY divided by the determinant of A. And in this case, if we calculate these values, we get something like 48 divided by minus 16, this would make it a minus 3. And now the last one, let me put this here because I don't want to write all of these. So here we have 7, minus 3, 5. And in this case, we would have the following. Let's clean this a little bit. Here we have 1 times 10 plus 3, 13, minus 2 times minus 5 plus 12, 7, minus 2 times 7, plus 7 times minus 1, minus 8, minus 9. This is minus 9, okay? So this is something like 2 times 7, this makes it minus 14, that's minus 1, minus 1, minus, what is this, 63, this makes this minus 64, okay? And minus 64, which is 2 to the power 6, we get here Z is equal to minus 64 divided by minus 16, and this will be equal to 4. Okay, so we apparently, if these two conditions are satisfied, so that the matrix A is a square matrix and the determinant is different from 0, we can easily find these solutions using this specific rule. Okay, is it clear? And by the way, so what right now it's okay. So this was the Cramer's rule, and I think what time is it? It's okay, so let's do an example here. So can we find the inverse of this matrix? So what is the first thing we have to check?
If the determinant is 0.
That's true. So this will be, let's expand over the first column, and here we have 2 times minus 2 plus 1 plus 3, 4 plus 4. This makes this 0. Okay, is this correct? Okay, can you check this again? So you have that's 2 times minus 2 plus 1 times 1 minus 4. Okay, that's true. That's 0. So this is equal to 0. What if we put here? So this matrix, the determinant is 0. This implies that A inverse
doesn't exist.
That's correct. We see that this does not exist. Then let's write a similar matrix B, which is equal. Let's change only one number: minus 2, 1, 3, 0, minus 1, 1, 1, 2, 0. So what would be the? Let's check again if the determinant is 0. Probably that might not be the case. So at least it could be a little different from the previous example, because here we're going to have here a minus 2. Is it the only thing that changes? I believe it is. So the determinant. So let's do it here. Determinant of B.
It's 7.
7 or 8? Is it 7 or 8?
8.
8, okay. If this is 8, then which way would you like to follow to find the inverse? I mean, so far, we have two different techniques that we can implement. And so, this says, so which method would you like to follow? You pick one, or you're going to do both. The first one is we can make it reduced row echelon form. The second one, I forget, what was the second method? So the first approach is try to obtain a reduced row echelon form, which in principle would be equivalent to getting the identity matrix. And what was the second method? So the second method was this. We calculate the minor, the cofactors, and the rest. So let's start with B, but let's write, if you allow me, we can, what help would you accept if we interchange row 1 with row 3? Because it will help us because we'll get a leading one in the first row, which we can make it then a pivot row. So
It's better to use the second method.
you'd like to use the second method? Okay, let's do that. So if you want to use that, then let's try to identify. So we have the B. Let's try to identify the minor. What is the minor matrix? So first, let's try to identify what is, we can even write it. So what is the determinant or what is the minor of this element? It will be the determinant of this little matrix, right? So what is the first number?
Minus 1, 2, 0.
Minus 2. What about the other number?
Minus 1 or 1. What is minus? Minus 1, yes.
I think you were right. What about the next one?
1.
Okay, the next one. Minus 6. And then we have 2. Sorry, that's 0. Minus
3.
Minus 3. That's correct. And then we have minus 4, minus 1.
Minus 5.
Minus 5. That's true. And then we have 1 plus 3, 4. And here we have minus 2. And this would be 2. Okay, we found the minors. And then what is the next step? We find the cofactors. Okay, cofactor matrix here. How do we find it? We keep the same value here. We change the sign. So we change the sign of these elements, which are minus 1s. This is minus 2, minus 1, 1, 6, minus 3, 5, 4, 2, 2. So we found this, and then we determine what is the adjoint. This would be equal to, let's get the transpose. So let's get the first row. What is the first row? Minus 2.
It turns into the first column.
That's true. The second row, 6 minus 3, 5. 6 minus 3, 5. It becomes a
And the
column.
third column is 4, 2, 2.
We get here 4, 2, 2. That's true. And now the final, the inverse, this will be denoted as, so A inverse, this is equal to 1 over 8 times the adjoint. So here we get minus 2, 6, 4, 2, 2.
Is it B inverse?
This is the inverse, yes.
No, B inverse, because we found for the matrix B.
Oh yes, that's true. This is B inverse, yes. This is B inverse. Because the A, it did not even exist. So this was the first method. Let's try also the other method, which is the reduced row echelon form. So here, let me think for a moment. Let's try this. Okay. Let me think. So we want the reduced row echelon form.
Should we interchange the third row with the first?
Let's start with that, yes. So here we have 1, 2, 0. Or you know what? We can even, let me think, just give me 1 second. We can also do this actually. Why don't we do it this way? So this is relatively easy, but let's do the following. Let's start with saying row 1 is equal to row 1 divided by minus 2. Let's do this. Then what we get is that we get 1 minus 0.5, plus 1.5, 1.5, and then we divide by minus 2, so this becomes minus 0.5, 0, 0. It would be the same thing, okay, so we don't lose much. So here we have 0 minus 1, 1, 0, 1, 0, 0, 1, 0. And then the rest is, let's keep it like this. Or, in fact, we can do this right away because we have written on the board, we have the first row, which is modified. We can say that row 3 star would be equal to row 3
minus row 1.
yes, minus row 1. So let's read row 3 over there and let's subtract these numbers that are here. So we have 1 minus 1, this is 0. 2 minus 0.5, what is it? 2.5. 0 minus 1.5 minus 1.5. No, is it? Yeah, that's true. Okay. Then we have 0 minus 0.5. This is 0.5. Then we have 0 minus 0. That's 0. Then we have 1 minus 0. This is 1. Okay, we got this. What is the next step? Next step is to get the leading one here. How can we get the leading one here?
Multiply second row with minus 1.
Yes, let's make it like this. Okay, done. Now that we got this, what is the next step? The next step, we want to make this 0. Okay?
We have to make 2.50.
Yes. So how can we do it? We can say that row 3 star would be equal to row 3, then what?
2.5 row 1.
That's true, minus 2.5 row 1. And then
Isn't it row 2?
Row 2, not row 1.
that's row 2, that's true. That's row 2. That's row 2, and here we would have, this will not change, 0, 1, minus 1. And here we have 0, minus 1, 0. And row 3, it will be the following, 0, 0. Then this is minus 1.5, plus 2.5, we get 1, right? We get 1 here. You can correct if I made any mistake. But then here we have 0.5, this would be 0.5, nothing will change, 0.5. Then this would be 0 minus 2.5, which would be 2.5. And then we have row 3, okay, we get 1. Then let's bring back this 1. This is 1 minus 0.5, 1.5 minus 0.5, 0, 0. Then, so we achieved the first objective, which is to make all zeros down here. And now we want to produce zeros. We want to make these two elements as 0. So the steps that we can follow is that we can say that row 2 star is equal to row 2, then what?
Plus row 3.
Yes. So row 3, it is 0, 0, 1, 0.5, 2.5, 1. And then here we get, so we just add the bottom 2 rows. 0 plus 0, it's 0. 0 plus 1, it's 1. This would be 0. And this would be 0.5. This would be
1.5.
yes, 1.5. Then
1.
1. Okay. And then how can we make this 0, this row 1?
Minus 1.5 row 3.
What if we make it plus? No, I was mistaken. Sorry. You said
Minus 1.5 row 3.
yes. Okay, you are right. For a moment, I was reading something wrong. So this means that row 1 minus 1.5 row 3. So this is 1. Then we have 0.5. Sorry, minus 0.5. This remains the same. Minus 0.5. Then we get 0. And then row 1 minus 1.5 row 3. So this is going to be minus 0.5 minus, I cannot do this one very correctly, so this is going to be minus 1 over 2, which is this number, minus 3 over 2 times row 3. Row 3 is 1 over 2. Okay, this makes this 1, minus 1 over 2, minus 3 over 4. So 2, 4, this is equal minus 5 over 4. And correct me if I'm wrong. Minus 5 over 4, this is minus 1.25. Minus 1.25. If you have a calculator, you can do a faster job than me. But then here we have row 1 minus row 1, this is 0, minus, so here we have 0,
Minus 3.75.
3.75, okay, and here this one, minus 3.75, okay, what is the last one? This would be 0 minus 1.5, right? Minus 1.5. So this is what we get. Then the last step is to make this a 0. How can we make this 0?
R1 is R1 plus half of R2.
Plus 1 over 2 R2. Okay. So this is going to be, well, this one is easy. 1, 0, 0, 0, 0, 1, 0. 0, 0, 1, and here we have the following. So let's keep this is not changing, 0.5, 2.5, and 1, and then we have 0.5, 1.5, and 1, and then okay, this comes
minus 1.
This is minus 1.
Yes, the first.
And then
minus 3, I guess.
Okay.
No.
Let's think for a moment. This is minus 3.
Minus 3.5, I think.
Plus, this is plus half, plus 1.25, plus 1.25. So this would be equal to minus 2.5, minus 2.5. Minus 2.5, and then we have here again minus 1.5 plus 0.5
minus 1.
This is minus 1, okay? So this is what we get. But I don't like this very much actually, because let's think for a moment. This is the inverse, right? Yes. So if this is the inverse, then the inverse should have minus 2 divided by 8, we should have minus 0.5, whatever is in there. 0.25, 3/4, okay. Did we make any mistake then? We got 6. So in fact, the common, actually, was the determinant really 8? So if we check this again, this is minus 2 times 0 minus 2, which is 4. Yes, this is 8. But what did we make a mistake here? I cannot see it. But why don't we do this actually? Shall we try this one for a moment? Let's see. Let's check whether we got the correct answer here. So let's multiply this b here. Let's multiply with minus 264. Minus 2.
If it is equal to its identity, it is true.
Which one? It is true to. No, but the thing is that this should be the inverse, okay? This should be the b inverse. And if this is the b inverse, we see that it's not equal to this number. We should have gotten the same number. So this is something like, this is -1, and this would be 0.5, but this is not 0.5, this is 0.125.
No, I said that we should multiply matrix B with its inverse.
Yes, okay, that's what I'm trying to, we can try them together to check whether the numbers will match.
To check the identity.
Yeah, that's correct, okay. 1, 5, 2, and let's see. Here we have, so -2 is, okay, so then we're going to divide by 8. So let's see, allow me to erase this one, and let's see what we have here. -2 times -2, this is -4, +1, -3, minus.
It's 4, not -4.
Okay, that's true. That's 4 plus 1, 5 plus 3, 8. That's true. So we get an 8 here. Then let's multiply this one with the second column. This is -2 times 6. This makes this -12. Minus
Plus 6.
15, we get 0. Then this one, 2 times 4, -2 times 4, this is -8, plus 2, and 6. This is also 0. The second row, we get 0, -1, 1, we get 0 here. The second row, with the second column, we get 0, 3, 5. Is it true? I think we get an 8 here, yes. Then the second row, with the third column, we get 0, -4, and, sorry, I cannot see, 0, who can help me here? So we have this row with this one.
-2.
-2 to 0. And then we get the last one, we get -2 to 0, 0. Then we have 6, -6, 0, 0. And the last one, we multiply the third row with the third column. We get here 4, 4, 0. So we get 8. Okay. So if we multiply these two, we get this 8. But in fact, we have also to include 1/8 factor, which
We can divide it by 8.
Yeah, so it looks like this value is correct. Okay. So apparently this is correct, but we might have done some mistake in this part. But it's good that we confirmed that we have this. So apparently we are good here, but we are not performing very well here. So we divided by 2. We got. Oh, okay. No. I think probably I found a mistake. Why did we start with 1 here? Oh, we changed. No. This was the mistake. So no. We divided by -2. This should be 1. Okay, 1 divided by -2, we get minus 0.5. Okay, here is the mistake. When we divide with -2, we are missing this minus here. Okay. Yeah. So I think that's it. That's it. But how can we fix this? This is not relevant in this step. So we do this correctly. This is going to be another -5, -1.5, and that -1.5, that equation would have been like row 1 plus 1.5, row 3, right? Plus 1.5 for row 3. This would be we'll get a 0 there, but we have -0.5 for row 1. I want to modify this plus 1.5 times -0.5. No, wait a second. Row 1. No, I think that's enough. Actually, is it all? It looks like we're fine then. Only that. Plus 1. We have row 3. No, we have row. Okay, so this would be 1.5 row 3. So the major modification would be in the top half, I believe, because we're going to have, if we notice this row here, most probably we can figure it out. It's not a big mistake, but this is minus 1 over 2 plus 3 over 2, which is 1.5, times 1 over 2. So we're looking at this row 1 and row 3 here. So this is equal to minus 2 over 4 plus 3 over 4. This is 1 over 4. 1 over 4, we write this in here. So 1 over 4 is 0.25. Then this is 2.5, this is 0 plus 3 over 2 times 5 over 2, this is 15 over 4. 15 over 4, what is this equal? This is something like 3.75. Oh, it did not change? How is it possible? Oh, this plus, okay, plus 3.75. I'm a little surprised that it is like that, but apparently that's true. So, yeah, 3.75, that's correct, yes. And then finally, we have 1 plus 1.5, this is like this, minus. Okay, so probably we are improving this one. And finally, okay, so we have these numbers, and then we add half of the second row, then we would modify this one, because we have 0.25 plus this half, plus 0.25, this would be 0.5. Okay, I don't see much light here, but 3.75 plus 3.75. Anyway, could you please go over this one? Most probably we made some small mistake on the path. This is more trivial, actually. So we got this correct, okay? These steps, when we do the reduced row echelon forms, these are almost a little more trivial. So I'm sure you could, you're going to get the correct values, okay? So we should get something like this, like these values. But I don't think, so shall we pass this one and you check this one on your own?
Yes.
Okay.
Okay, thanks for confirming. So at least we should get something like this, which we just found it together. Okay, so we were dealing with the determinants. We looked how determinants can be used to find systems of equations. And another aspect of importance is that this is actually almost most of the chapter 3. And chapter 3 has a bonus section, which is talking about some input-output analysis. For some of you that are interested, you can go over it. Okay, it's not that this is required, but we could go over it. But since it's a bonus topic, we are just going to skip. Okay. Do you have any question, or do you have anything which is not clear? Anything?
No.
Okay.
It's all clear.
Okay. Okay, then if this is all, if you have no questions, probably we can end this for today.